Hello, this is Ken Titmus again with the third in the DDMRP podcasts. Today we'll be taking a brief look at the second and third components of DDMRP, namely DDMRP buffers and buffer profiles, as well as dynamic buffer adjustment. I say a brief look as these podcasts can't really go into the depth of understanding required, but hopefully inspire your curiosity to do further research and maybe take the Demand Driven Institute Demand Driven Planner course. If you've been looking at the DDI website, you will see that there is also a Demand Driven Planner Professional Certification exam that you can take. There are plenty of details on the website on how to go about this and what is required. So recapping, we have looked at why we need to seriously look at changing the way we have traditionally been planning our businesses and what becoming demand driven really means. Last time we went through the first component of DDMRP, strategic inventory positioning, and now we will continue with the second component, buffer sizing and buffer profiles. In this section, we will look at when inventory is regarded as being an asset or a liability, list some of the factors to be considered when constructing DDMRP buffers, as well as understanding the logic and purpose of the three different zones in the buffer. Firstly, when do we consider an item of inventory to be an asset or a liability? Well, if we have very little inventory or we are out of stock or worse still we have back orders, this is a liability. We miss sales, short deliver or expedite deliveries to replenish the stock. These all cost us money and hence are a liability. At the other end of the scale, if we really have too much inventory for our immediate needs, then we spend money on something that is not giving us a return on the short term and hence is a liability. Not only that, stock could become obsolete or expire and will have to be destroyed, which is also a liability. So between these two high and two low points, inventory is regarded as an asset. However, as we progress to the 0 point or point of too much, the return on that investment will diminish. Therefore, at a midpoint between 0 and too much, we will get the greatest return on our inventory investment. In practice, when we analyze the complete stock in a warehouse, we typically find that too many of the SKUs have low inventory or are out of stock, and an equal amount are in the level where there's too much. Generally, we find only a small number of SKUs sitting in the ideal position for a maximum return on inventory investment. We also find that using traditional MRP systems, an item can quickly move from having too much to too little, with a requirement to immediately replenish the item due to it violating safety stock levels and hence putting it back into the too much category. So we end up with what we call bimodal inventory distribution. We need to get to a point where the majority of our SKUs are sitting in the optimal range for maximum return on investment, and those out on the tails being investigated for the reason why and changing their operating model parameters to bring them into line using a process of continuous improvement. In order for this to happen, we need to create stock buffers at our strategic inventory positions. These stock buffers consist of three zones: red, yellow, and green. And each of these zones have a specific purpose in the buffer. Let's take them one at a time. The yellow zone is the area in the middle of the buffer. We usually calculate this one first as it's the easiest and is the heart of the demand coverage in the buffer. It is always calculated using the lead time and multiplying it by the average daily usage, called ADU. Maybe at this point we need to address the issue of which lead time to use and how we determine the ADU. Lead time in days is the total length of time it takes for inventory to be replenished in the buffer. For the buffer of a purchased raw material or component, it will be the purchasing lead time. If it is a manufactured item, then we would use the decoupled lead time or DLT mentioned in the previous podcast. For an SKU at a distribution center, it will be the transit time to replenish the stock from the supplying location. With regards to ADU, this can be calculated in three different ways. For most items in a location, it will probably use a backward-looking ADU. Here we might take the last 90 days of demand and work out the ADU by dividing the total demand over this period by the number of days. For an item that has no past demand data, we would probably use a forward-looking ADU known as FDU, taking the total of, say, 90 days of forecast and dividing by the number of days again. There is another option of a blended ADU. In this case, we take some past data as well as some forecasts to come up with a number. What is best for each SKU at a location will need to be determined by the project implementation team, maybe using some simulation tools. The top zone of the buffer is the green zone, which is the heart of the order generation aspect of the buffer. It determines the frequency of reordering and the typical size of the orders. We calculate the size of this zone in 3 possible ways and typically select the number which is the largest. The first method of calculating the green zone is to see if there's a significant minimum order quantity or MOQ when this item is manufactured or purchased. Secondly, we determine if there is a cycle to purchasing or manufacturing the item. So, for example, we might want to make an item in the factory every 2 weeks, or we might want to buy products from a supplier once a month. We then take the cycle in days and multiply it by the ADU, and we come up with a number. The third method is to take the size of the yellow zone and multiply it by a lead time factor, or LTF, which we will define shortly. This method again will give us a number. We compare these 3 numbers and generally take the largest as the size of the green zone. The lead time mentioned previously is determined by the length of the lead time to replenish the item of inventory. For short lead times items, we would use a factor between 0.6 and 1. For medium lead time SKUs, a factor between 0.4 and 0.6, and for long lead time items, a factor between 0.2 and 0.4. This is not intuitive, as we use a small factor for long lead times and a large factor for short lead times. The reason is that for long lead time items, we want to generate smaller green zones and hence more frequent orders to promote flow, reduce risk in the supply chain, and give us better cash flow. The factor you use for your SKUs again will be determined by your project team. So now we have calculated the size of the yellow and the green zones, we now need to determine the size of the red zone. The red zone is the safety in the buffer, but it is not safety stock and doesn't behave in the same way as safety stock. It is really the shock absorber for the demand or supply variability at this point in the supply chain. The red zone is broken down into 2 parts, the red zone base and the red zone safety. These parts are calculated separately and then added together to determine the size of the red zone. The red zone base is calculated as the lead time times the average daily usage times the lead time factor. In other words, it is the same as the green zone if we use the lead time factor option. The red zone safety is calculated by taking the red zone base and multiplying it by the variability factor and adding the 2 portions of the red zone together to get a total. The variability factor, as opposed to the lead time factor, is intuitive. With high variability, we use a high factor of between 0.6 to 1, medium variability 0.4 to 0.6, and for low variability 0.2 to 0.4. The variability of each SKU needs to be determined by the implementation team, but one can use a coefficient of variability factor to assist in the process. The coefficient of variability, or COV, can be calculated by dividing the SKU's demand standard deviation by the ADU. So now we have the size of the 3 zones in the DDMRP buffer. In DDMRP speak, we talk about top of red, which is the size of the total red zone, top of yellow, which is the red zone plus the size of the yellow zone, and top of green is the top of yellow plus the size of the green zone. Over this number, we talk about over top of green, or OTOG for short. To make things easier for the system to complete the calculations, we need to set up buffer profiles to which we will assign each and every SKU. The buffer profiles matrix is initially sectioned into major categories of inventory: purchased, manufactured, intermediate or subassemblies, finished products, and distributed items. Within each of these inventory categories, we divide the matrix into long, medium, or short lead times. These lead times are then divided into high, medium, or low variability categories. This gives us about 45 buffer profiles to which we allocate all our SKUs. The system then knows how to perform the buffer sizing calculations for each item. So, for example, if we have a manufactured item, M, with a short lead time, S, and a medium variability, M, it might be allocated the buffer profile code of MSM. In the 2-day DDI demand-driven planner course, we go through a number of exercises to ensure participants are proficient in calculating buffers. Now we have the buffer profiles and buffer sizing organized, we need to dynamically adjust the buffers to take account of constant changes in the external trading and business environment. So now we will look at the third component of DDMRP, dynamic adjustment. Under dynamic adjustment, there are two issues we need to discuss: recalculated adjustments, and secondly, planned adjustment factors. Let's first discuss recalculated adjustments. These adjustments to the buffers are done automatically by the system when any of the key parameters in the part change, such as lead time, average daily usage, minimum order quantity, buffer profile, lead time and variability factors. So buffers are keeping up with changes to your business environment virtually in real time. Over and above these automatic adjustments to the buffers, we have the ability to apply manual planned adjustment factors for various circumstances. Here we basically have three types of adjustment: demand adjustment factors, zone adjustment factors, and lead time adjustment factors. Demand adjustment factors are used mainly for SKUs which have a strong seasonality. In that case, the average daily usage is multiplied by a seasonality index to increase the size of the buffer into the future to take account of greater sales in the high season. These seasonal indexes are then reduced after the high season to bring the buffers back to the normal low season size. Demand adjustment factors can be used to ramp up demand for a new product or ramp down products at the end of life, or a combination of both for a product transition. Zone adjustment factors can be applied to each of the three zones individually for various reasons. For example, we could adjust the green zone to manipulate order sizes and frequency of ordering. The yellow zone could be adjusted because of a temporary change in lead time for various reasons, but not warranting a change in the part's basic planning data. The red zone could be adjusted due to a temporary change in variability, which might be due to strikes at ports or transportation, or in the manufacturing plant, not warranting a permanent change in the buffer profiles. The lead time adjustment factor could be used for a single or groups of items where lead time increase or decrease due to the season or an event. For example, lead times tend to extend during Chinese New Year. So for SKUs coming from this region, the buffers should be expanded during this period. The same thing could happen when it's summer holidays in Europe during July and August. Business tends to slow down somewhat. The DDMRP implementation team will need to determine how and when to use these adjustment factors, which will vary with different businesses and products within the company. We have now completed the first three components of DDMRP. 1. Strategic inventory positioning. 2. Buffer sizing and buffer profiles. And 3. Dynamic adjustment, a buffer adjustment. In the next podcast, we will go through what I think is the most elegant portion of DDMRP, and that is demand-driven planning. Up to this point, we've basically covered the first day of the Demand-Driven Institute's Demand-Driven Planner course. Bearing in mind that these 3 podcasts have taken about 40 minutes, one can appreciate that there is a lot more to learn and know on the subject. It's therefore important that if you want to start a demand-driven journey, you need to attend the Demand-Driven Planner course and ultimately take the Demand-Driven Planner Professional Certification exam. More information on this course and other demand-driven educational offerings are available on the DDI website, www.demanddriveninstitute.com. If you sign up on this website, and it's free, you'll get extra demand-driven material on the On Demand tab. And don't forget to look at the case studies and presentations which are available from recent demand-driven world conferences. You will find a list of global DDI affiliates on the website. Contact one today in your area and see what they have to offer. I'm Ken Titmus, and you can get hold of me on ktitmus, that's KTITMUSS, at mweb.co.za. So until next time, goodbye.